Tree diagrams are a way of showing combinations of two or more events. The outcome is written at the end of the lines or the branches, and the probabilities are written alongside the lines. These tree diagrams can be used to show independent events, like rolling a dice a number of times, or conditional events, like taking biscuits out of a tin and eating them. They provide a great method for working out probabilities, making sure that you haven't missed out any combinations. So this video, I'll give you some examples and they're to help you do the online exercise. And you can see the address down below. Let's begin with an example. The probability that the daily flight from Bangkok will be more than half an hour late is 0.4. That's the chances it will be more than half an hour late, about 40%. What is the probability that the flight will be more than half an hour late on both days this weekend? And part B, what is the probability that the flight will not be more than half an hour late on at least one day this weekend? So we're looking for combined events, two things, 2 days, a Saturday flight and a Sunday flight. So let's draw a tree diagram to represent this. Well, it's usually easy to get started. We just choose a point on the left side of the page and draw a line, and then another one going down at about the same angle as that one was going up and about the same length. But it doesn't have to be exact. This is just a diagram to help us do a calculation. And this represents the flight being late. And this represents the flight not being late. So I'll just put late and not. Now, this represents what happens on Saturday. Next, we'll show what happens on Sunday. Now, in this case, we'll represent what happens on Sunday following what happened on Saturday. So if the plane was late on Saturday, it could also be late on Sunday. Or maybe it's not. So these are the two possibilities, assuming that it was late on the Saturday. Now, if it wasn't late on Saturday, it might still be late on Sunday. So we'll draw a line to represent late or not. So we'll represent a line down here to represent not. And you can think of this as a journey. So if these were roads, you could go along this road and then along this road. And that would represent, in terms of the flight from Bangkok, the flight being late on Saturday and late on Sunday. Or maybe you choose to take this road. So this would represent the flight not being late on Saturday. But if you then went up here, the flight on Sunday was late. So you can see all the different possibilities are represented in this diagram. What we then normally do is write down next to the lines the probability of them happening. So the probability that it is late is 0.4. So the probability that it is not late, there's only two possibilities, late or not late. So this one must be 0.6 because these two numbers add up to 1. And there's a certainty that it must be one of those two. So here, this doesn't change. On Sunday, the probability late is 0.4, not late is 0.6. 0.4, 0.6. So part A of the question asks, what's the probability that the flight will be more than half an hour late on both days? Late, late. That's this route here. And what we do is we multiply these two numbers together, these two probabilities. 0.4 multiplied by 0.4 equals 0.16. So that is the answer to part A. The probability that the plane is late on both days is 0.16. Now we could work out the probabilities of all the other possibilities. So late on Saturday but not late on Sunday would be 0.4 times 0.6. So those are the probabilities of these events occurring. Late, 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 not late, not late, late, not late on either day. So part B of the question, what is the probability that the flight will not be more than half an hour late on at least one day? So we're looking for not late on at least one day. So it could be not late on the Sunday, it could be not late on the Saturday but late on the Sunday, or it could be not late on the Saturday and not late on the Sunday either. So it's these three. So what we do here is we add these three probabilities together, and that's how you get the answer to part B. So those three decimals added together is 0.84, and that's the probability that the flight will not be more than half an hour late on at least one day. Now, a quicker way of adding these three probabilities together is knowing that all four of these probabilities have to add up to 1, because it's certain that one of those four events will happen. So a quicker way of doing it would have just have been subtracting 0.16 from 1 to get the answer 0.84. That's a quicker way of arriving at the answer. So let's pause a moment here and just get one thing straight. It's the sort of thing that many students forget, so I'd like to really emphasize it now. And that is that you multiply along the branches of a tree diagram, but you add the columns. So this is a tree diagram for some other situation. So for example, if you wanted to work out the probability of a square followed by a red, it's a multiplication to give you the answer. So multiply along the branches, that's another way of doing it there, or maybe down here like this. But it's definitely always multiplying along the branches to get the probabilities at the end. But when you've done that, you can check your answers by looking at the columns. So that pair of values there must add up to 1. It's a certainty that either a square or something circular has been chosen, so nothing else can happen. Those two must add up to 1. And there's lots of different places you can check that sum of 1. Even your calculations at the end, they should always add up to 1. So remember that. Multiply along the branches, but add the columns to check that they are equal to 1. Another example. I've got two tins here. This tin has got 3 orange cubes and 2 blue cubes. And this tin here contains 4 orange cubes and 1 blue cube. And this second example is about someone called Owen choosing one of these tins at random first, and then when he's chosen a tin at random, puts his hand inside and picks out a cube at random. And we want to represent this situation with a tree diagram. Two situations. One of them is choosing the tin, and the second part is choosing the cube. So I'll start right over on the left of my page and put a dot, and then draw my 2 lines to show this first choice. And this will be choice A, and this will be choice B. And then Owen chooses a cube. So I'll draw the second set of branches over here. And then this will represent him choosing an orange cube. And this will represent him choosing a blue cube. Orange and blue. Now, what's the probability that he will choose tin A? Well, there's an equally likely possibility of him choosing either tin, so it's going to be a half. And if the probability of choosing A is a half, well then the probability of choosing B will be a half also. Those two will add up to 1. Now, if he chooses tin A contains 2 blue cubes and 3 orange cubes. So that's 5 cubes altogether. So the probability of choosing an orange cube will be 3/5, and the probability of choosing a blue cube will be 2/5. But if he chooses the second tin, we'll call it B, this contains 4 orange and 1 blue. So that again is 5 altogether. 4 of them are orange and 1 is blue. So those two fractions will add up to 1 and those two fractions will add up to 1. Right, remember we multiply along the branches of a tree diagram. So a half times 3/5 equals 3/10. What about if he chooses A and then he picks out a blue cube? That will be a half times 2/5. And then this root, a half and 4/5. And then a half and 1/5. Multiply them together. Now let's check we've done the calculations correctly. Remember, all of these probabilities must add up to 1, because one of them must happen. It's a certainty that one of them will happen. Now, when I got a fraction such as 2/10, I actually didn't bother to cancel it down to its lowest terms, because it's actually easier to consider them all with the same denominator, all as tenths. So I've got 3/10, 2/10, 4/10, and 1. That makes 10/10 altogether. That's a whole. Yeah, so I think I've done the calculations correct. All right, now let's read the question in detail. What is the probability that the cube Owen chooses is blue? Well, we need to say there are 2 situations where he could choose a blue cube, either a blue cube from tin A or a blue cube from tin B. So it's going to be these 2 numbers here added together. 2/10 and 1/10, the answer is 3/10. So the answer to that question is 3/10, or 0.3, or 30%. That's the probability that he will choose a blue cube. Example 3. A bag contains 3 red pens, 2 blue pens, and a black pen. Zoe takes out 1 pen at random for her schoolwork one morning, but does not put it back in the bag. That afternoon, she takes another pen out of the bag. What is the probability that the 2 pens chosen that day were of the same colour? So here's the bag, and let's have a look inside. Here are the pens. So there are 3 red, 2 blue, and 1 black. So I think we need to represent the situation as a tree diagram. Surprise, surprise. Okay, let me think. One thing happened in the morning and the other in the afternoon. So I'm going to have one stage of my tree diagram for the morning and one for the afternoon. Now, this time there are three possibilities in the morning. She could either pick a red, a blue, or a black pen in the morning for her schoolwork. So I've shown this as a tree diagram with three branches. And now, after each of these particular choices, we need to show what could have happened in the afternoon. So, let's see. And as I'm drawing this, I'm realizing that because there is only one black pen in the bag, if she takes the black pen out in the morning, she won't have that choice in the afternoon because the pen has gone. So there are only two choices in the afternoon if she picked a black pen out in the morning: red and blue. Right, so now we need to write on the probabilities. So I think there are 3 red pens, and altogether there are 6 pens in the bag. So I'm going to write that down as 1/2. 3 red pens out of 6 pens altogether, so the probability is 3 out of 6, which I've reduced to its lowest terms, 1/2. The blue pens, there are 2 blue pens out of 6 altogether. 2 out of 6, that can be written down as 1 out of 3. And there's only 1 black pen, so that's 1 out of 6. Now, when she's taken 1 pen out of the bag, there are only 5 pens left in the bag. So I know that these fractions are going to have a denominator of 5. So if she's taken 1 red pen out of the bag, that will leave just 2 red pens out of 5 in the bag. So that fraction will be 2/5. If she's taken a red pen out, there'll still be 2 blue pens in the bag, so this fraction will be 2/5 as well. And there's only 1 black pen, so that'll be 1/5. Just check that those 3 numbers add up to a whole, or 1. Yes, they do. And those 3 numbers add up to a whole as well. All right then, let's say she's taken 1 blue pen out of the bag. There'll still be the 3 red pens in there, so that fraction will be 3/5. But there's only 1 blue pen left now, so that'll be 1/5. And there's 1 black pen, so that's 1/5. Just check that those 3 add up to a whole, or 1. Yes, they do. So if the black pen has been taken out of the bag, that leaves the 3 red pens out of the 5 left in the bag, and the 2 blue pens out of the 5 left in the bag. Now we have to work out the probabilities of 2 events occurring over here. Now we don't need to do them all. We only need to do the ones that are going to contribute towards our answer. And the question said, what is the probability that the 2 pens chosen that day were of the same colour? So, which branches of the tree represent 2 pens of the same colour? It could be red followed by red. So I'll remind myself by putting a box there. Or it could be blue followed by blue, so that situation is here. Or it could be black, and there isn't another black to take out, so it definitely won't be this situation. It could either be 2 blues or 2 reds. So now I'll do the calculations. Remember to multiply along the branches. 1/2 times 2/5. That's equal to 2/10. I'll leave them as tenths. It might make the addition a little easier in a moment. What about 2 blues? That's 1/3 times 1/5. So the answer to the question is these 2 probabilities added together. So that'll be 2/10 added on to 1/15. Well, actually, it probably would have been easier to change this into fifths. So 2/10 is the same as 1/5 plus 1/15 equals, the lowest common denominator is 15. So that will be 3 plus 1 is equal to 4/15. That is my final answer. Okay, now it's your turn to have a go at the online exercise. Don't forget to press the check button regularly as you're working through the questions to see if you're getting them right. And if you make a mistake, have another think and correct your answer and then press that check button again. Don't forget to claim your trophy when you've got to the end. And there are lots more activities on the Transom website for you to have a go at to improve your mathematics, and you can claim hundreds of trophies. So, what are you waiting for? Get going! Bye!
You can find Transom Mathematics at www.transom.org, where you're welcome to use all of the activities absolutely free. Or jump in with both feet and become a Transom subscriber.